Okay, hi guys, welcome back. So we are still in the same subtopic, which is inverse Laplace transform of a rational function. So we are going to proceed with the third example, which is this function. So let's consider your fs is equals to s squared minus 3 over s minus 3 squared s plus 1. Okay, so identify first what is the factor, either linear or repeated linear or quadratic or repeated quadratic, okay, by looking at the denominator here. Okay, so as you can see here, this is repeated linear function, so this is a second case. Okay, and this is a linear factor, which is the first case. Okay, I consider by using this one. Okay, so the first one is a repeated linear, the second case, and this is a linear factor, which is the first case. Okay, so since you already know, so you can write down your partial fraction that is suitable with the function. Okay, so s squared minus 3 over s minus 3 squared s plus 1, which is equals to, so this is a repeated linear function, so the first one is a over s minus 3 plus b over s minus 3 the whole thing squared, and the last one is a linear factor, so plus c over s plus 1. Okay, so as you can see here, you cannot get the inverse of this one. This is a very complicated function, but when we are using properties of Laplace transform, which is inverse Laplace transform of a rational function, so you just need to get the inverse of this function. Okay, so the next step is for you to get the value of a, b and c first. So on your left hand side you have s squared minus 3 is equals to, so a. So compare this one with what you have on your left hand side. You have s minus 3, but this is one term. Okay, but this one is squared, so you miss another term. So you need to multiply by s minus 3. And another one is, this one is missing, so multiply by s plus 1. Okay, so for the second term here, plus b, so when you compare this one with what you have on the left hand side here, you already have s minus 3 the whole thing squared, so what is missing is s plus 1, so that's why this one just multiply by s plus 1. And the last one is plus c, so as you can see here, this is s plus 1, so you already have this one, so the one that is missing is s minus 3 the whole thing squared. Okay, so now you need to expand every single thing here and factorize according to the variable. Okay, so let's just do it. So you will have s squared minus 3 is equals to a, so you just factorize a first, so just expand this one first. So you will have s squared plus s minus 3s minus 3 plus bs plus b plus c. So expand this one will give you s squared minus 2 multiplied by 3 is equals to 6s plus 9. Okay, so expand this one will give you as squared. So this one 1 minus 3 will give you negative 2. So negative 2as minus 3a plus bs plus b plus cs squared minus 6cs plus 9c. Okay, so now factorize according to the variable. So the first one is s squared and this one is s squared. The second one is variable s, and s. And the last one is a constant. Okay. So on the left hand side you have s squared minus 3. So therefore if you factorize the first one you will have a plus c s squared plus, so variable s, then you will have negative 2a plus b minus 6c s. And the last one is a constant which is negative 3a plus b plus 9c. Okay, so form a 3 equation because you have 3 unknown. So the first equation will be a plus c is equals to 1. Okay, why? Because this one you have x squared, so the coefficient of x squared is equals to 1. So this is your first function. So the second one, compare with the variable s, so you will have negative 2a plus b minus 6c is equals to, so you don't have any s variable on the left hand side here, so therefore this one is equals to 0. And the last one is for a constant, so you will have negative 3a plus b plus 9c is equals to, so what is your constant on your left hand side? Which is negative 3. Okay, so get the value of a, b and c. So you will have equation unknown 3. So your a1 is equals to 1, your b1 0, your c1 is 1 and d1 is 1. For the second equation, your a2 is equals to negative 2, b is 1, c is negative 6 and d is 0. And the last one is a is equals to negative 3, b is 1, c is 9 and d is negative 3. So as you can see here, your a is equals to 9 over 8, your b is equals to 3 over 2, and the last one, your c is equals to negative 1 over 8. Okay, so therefore if this is your fs, so inverse of fs will give you ft. Okay, so therefore your ft is equals to, so the first one is a, so what is your a? 9 over 8 is a constant, so you just need to find the inverse of 1 over s minus 3. Okay, plus b, so your b is equals to 3 over 2, so factorize 3 over 2, so you just need to find the inverse of 1 over s minus 3 squared. Okay, and the last one is s plus 1, so your c is equals to negative 1 over 8, so you will have minus 1 over 8 inverse of 1 over s plus 1. So take a look at this function here. This one you can get directly from the table, and also this one, but for this one you need to apply something for you to get the inverse of the function. Why? Because you cannot get directly from the table. Okay, so when you cannot find the inverse directly from the table, you must come up with the properties. So we already learned linearity properties, or first shift, or another one is rational function. So choose which one is suitable for this kind of function. So as you can see here, you can apply first shift properties. If you don't know how to apply first shift, please go back to my previous video and watch it again. Okay, because I'm not going to explain it here. Okay, so therefore your final answer will be, your ft is equals to, where should I write it? Here. 9 over 8 exponent 3t plus, so this one will be 3 over 2 t exponent 3t. Okay, so if I do it step by step, so you will have exponent 3t, so inverse of 1 over s squared. Okay, minus 1 over 8 exponent, sorry, 1 over 8 exponent negative t. So this one will be 1 over s squared is equals to t. So therefore, your ft is equals to 9 over 8 exponent 3t plus 3 over 2 t exponent 3t minus 1 over 8 exponent negative t. If you don't know how from this one I get this function t exponent 3t, please go back to my previous video on first shift properties, Laplace inverse Laplace transform. Okay, so this is case 1 in first shift properties, inverse first shift. Okay, so the last example, let's say you have this function, your fs is equals to 4s squared over s squared minus 36 s minus 6. So now you have a quadratic function, so first you need to check either this function can be factorized or not. So equation degree 2, so your a is equals to 1, your b is equals to 0, your c is equals to negative 36. So as you can see, you have x1 is equals to 6 and x2 is equals to negative 6. So you need to apply, so therefore this one will be a linear factor. Okay, since you can factorize this function, so therefore 4s squared over s squared minus 36 s minus 6 is equals to a over, so as you can see here, just now you have the value of 6, so the factor will be s minus 6. Okay, we just first we just simplify this one. Okay, so you just have 4s squared here, so the first one is s minus 6, so the second one you have the value of negative 6, so therefore the factor will be s plus 6, and the last one here is s minus 6. So as you can see here, you have the same term, this one and this one. So if you simplify, actually what you have is 4s squared over, so this one you have 2n, so you will have s minus 6 squared, and the second one is s plus 6. So you are dealing with repeated linear and also a linear factor. Okay, so therefore the partial fraction will be a over s minus 6 plus b over s minus 6 the whole thing squared plus c over s plus 6. So please try to do on your own until you get the ft is equals to, so the last answer, you just proceed with the same procedure, same step that I teach you. Okay, so therefore your ft, you should get this answer. ft is equals to 3 exponent 6t plus 12t exponent 6t plus exponent negative 6t. Okay, So we are done with, okay, so in my next video I will show you another example which is uh, involving a quadratic function, because we don't solve any problem with a quadratic function. Okay, so stay tuned with me for my last example.